But GPUs don't look the way they used to. This is Hopper. Hopper changed the world. This is Blackwell. It's okay, Hopper. 208 billion transistors, and so you could see, I can see, there's a small line between two dies. This is the first time two dies have abutted like this together in such a way that the two dies think it's one chip. There's 10 terabytes of data between it, 10 terabytes per second, so that these two sides of the Blackwell chip have no clue which side they're on. There's no memory locality issues, no cache issues. It's just one giant chip. And it goes into two types of systems. The first one is form-fit-function compatible to Hopper. And so you slide on Hopper and you push in Blackwell. That's the reason why one of the challenges of ramping is going to be so efficient. There are installations of Hoppers all over the world, and they could be the same infrastructure, same design, the power, the electricity, the thermals, the software, identical, push it right back. And so this is a Hopper version for the current HGX configuration. And this is what the second Hopper looks like this. Now this is a prototype board. This is a fully functioning board, and I'll just be careful here. This right here is, I don't know, $10 billion. The second one's 5. It gets cheaper after that, so any customers in the audience, it's okay. The Grace CPU has a super fast chip-to-chip link. What's amazing is this computer is the first of its kind where this much computation, first of all, fits into this small of a place. Second, it's memory coherent. They feel like they're just one big happy family working on one application together. We created a processor for the generative AI era. And one of the most important parts of it is content token generation. We call it, this format is FP4. The rate at which we're advancing computing is insane, and it's still not fast enough, so we built another chip. This chip is just an incredible chip. We call it the NVLink switch. It's 50 billion transistors. It's almost the size of Hopper all by itself. This switch chip has 4 NVLinks in it, each 1.8 terabytes per second, and it has computation in it, as I mentioned. What is this chip for? If we were to build such a chip, we can have every single GPU talk to every other GPU at full speed at the same time. You can build a system that looks like this. Now this system is kind of insane. This is one DGX. This is what a DGX looks like now. Just so you know, there are only a couple, 2, 3 exaflops machines on the planet as we speak. And so this is an exaflops AI system in one single rack. I want to thank some partners that are joining us in this. AWS is gearing up for Blackwell. They're going to build the first GPU with secure AI. They're building out a 222 exaflops system. We're CUDA accelerating SageMaker AI. We're CUDA accelerating Bedrock AI. Amazon Robotics is working with us using NVIDIA Omniverse and Isaac Sim. AWS Health has NVIDIA Health integrated into it. So AWS has really leaned into accelerated computing. Google is gearing up for Blackwell. GCP already has A100s, H100s, T4s, L4s, a whole fleet of NVIDIA CUDA GPUs, and they recently announced the Gemma model that runs across all of it. We're working to optimize and accelerate every aspect of GCP. We're accelerating Dataproc, which for data processing, their data processing engine, JAX, XLA, Vertex AI, and Mujoko for robotics. So we're working with Google and GCP across a whole bunch of initiatives. Oracle is gearing up for Blackwell. Oracle is a great partner of ours for NVIDIA DGX Cloud, and we're also working together to accelerate something that's really important to a lot of companies, Oracle database. Microsoft is accelerating, and Microsoft is gearing up for Blackwell. Microsoft and NVIDIA has a wide-ranging partnership. We're accelerating all kinds of services when you chat, obviously, and AI services that are in Microsoft Azure. It's very, very likely NVIDIA is in the back doing the inference and the token generation. They built the largest NVIDIA InfiniBand supercomputer, basically a digital twin of ours, or a physical twin of ours. We're bringing the NVIDIA ecosystem to Azure, NVIDIA DGX Cloud to Azure. NVIDIA Omniverse is now hosted in Azure. NVIDIA Healthcare is in Azure. And all of it is deeply integrated and deeply connected with Microsoft Fabric.